Hello, dear students. Let's continue our discussion on circular queue using arrays. Just in the previous video, we saw in big detail how do you insert a new value in circular queue. We saw a function called insert, correct? And now in this video, we will see how to delete a value from a circular queue. Now I am not going through the call of the delete function from main. Everybody, I hope, is very comfortable that we will pass the address of the queue. So P is the pointer in the delete function, which will point to the queue, and we will handle the queue using this pointer P. Also, delete will not only delete the value but also return the value deleted. So it might return the value like 30 or 40 or 50 if these are the values stored in the circular queue. Let's find out how this delete function works. First of all, have a look at the queue, circular queue that has been shown here. If I ask you which are the values in the circular queue and give them in correct order, then your answer should be 60, 70, 30, 40, 50. It would be wrong. This is wrong answer. The correct answer is the first value in this circular queue is 30 because front, you can see the front counter is 2 here. So the frontmost element of the queue is not 60. The queue actually begins at the second location. And of course, after that, it would be 40, then 50. And then after 50, you will go circularly back to position 0 and say 60 is the next element and 70 is the rearmost. You can see that 70 actually is the rearmost because rear is having a value 1. You can think of this array as if it is circular in nature. There is nothing called circular array, but logically you can imagine that this is the array. Okay, and if this is the 0th element, first, second, third, fourth, then front actually is 2 as you see, and this element is 30, third element is 40, next is 50, 0th element is 60, and first element is 70, and 1 actually, position 1 is rear. So we have to carefully handle circular queue. It's not that the very first location of the array, that is 0th location, has to be the first element. You have to see what is the value of the front counter, and depending on that, you have to decide which is the first element and remove it. Okay, so you know by now that if you call delete on this particular circular queue, then 30 should be deleted first because 30 is the frontmost. Let's run this delete function. We have declared a local variable x where x will store the value of the frontmost element, p arrow front. Observe that p arrow front is 2. So second element of this array a2 will be stored by x. X has to be then 30. And finally, you see the last statement is return that 30 back to main. But what are we doing here after storing x as 30 is we ask, is p arrow front equal to p arrow rear? From the earlier video of linear queue, which also had delete function, you know that this is necessary to check whether there is only one element left in the queue. Now at the moment front is 2 observe and rear is 1. So they are not equal. But what if they were equal? If they were equal, it means the queue is becoming empty and we will make both front and rear equal to -1. But anyway, this if is false. So we land in else and execute this statement which says p arrow front should change equal to has been written. P arrow front should become p arrow front plus 1% size. Substituting the value of the front right now is 2, 2 plus 1. 3% size, remember size is 5, it's a hash defined constant, and 3% phi, the remainder, the mod 3% phi is 3. So the new value of p arrow front here becomes 3. It's quite obvious, isn't it? Tell me, if you are removing this 30, then next element should become frontmost, as we learned in even in linear queue. So front is no more 2, front has become 3. I mean, this statement, you see, such a big statement is same as front plus plus. Front was 2 and we have just made it 3. So one might wonder why such a complex statement has been written. If it is same as front plus plus, why is this written? You will see effect of this statement when we will reach the border or boundary of this queue, and we will circularly go back to 0th place by using mod operator. Okay, so P arrow front has been decided as 3, and finally we return X. That means we return 30 and deletion is completed. I'll just clean a few things. Now, as our habit goes, we will call this delete function again and again and see what will happen due to consecutive calls to delete function. Okay, let's get ready. Now, if you call delete second time, X will be equal to frontmost element of the array. Now front is 3 at the moment. Check here in the box, front is 3. In that case, this third element of the array will be stored by X. So obviously X will be 40, and it has to be because now the frontmost element of the queue is 40. We again ask, is front equal to rear? No, it isn't. Front is 3 and rear is 1. So it's not that whatever we are deleting, is not the only element. There are a lot of more elements in the queue. So it's not time to make the queue empty by making front and rear equal to -1. Hence, as the if is false, we go to else again, and front becomes front plus 1. Substituting the value of the front is 3, 3 plus 1. That's 4. 4% phi. The remainder is 4. So new value of front is 4. And it has to be, because if we delete 40, just check, 50 should become frontmost. That means now the new value of front is fourth location. So now, after deleting 40, that is third location, we have got front equal to 4. That is 50 is the frontmost. And of course, the last line is return X. So 40 is returned back to main. Okay, now it is very, very interesting. Just check what will happen. I'm just erasing the working that I have done here so that we can start with a fresh delete function call. Okay, what if we now call delete again? Now before you run delete, just ask yourselves which element should be deleted. Of course 50, because front is 4. And after deleting 50, which element should become frontmost? Yes, 60 should become frontmost. That means front, which is at the moment 4, should become 0, isn't it? Let's see. When we call delete, X will be equal to a p arrow front. A p arrow front means A4, because front is 4. So A of 4, which is 50, is stored by X, and finally we will return it. We ask, is front equal to rear, which is false. Front is 4 and rear is 1, so we land in else. And we execute front equal to p arrow front plus 1, which is 4 plus 1, which is 5. 5% size is also 5. Now 5% 5, the remainder is 0. That means new value of p arrow front, which was 4, you see p arrow front was 4 at the moment, becomes 0. I hope you're understanding. Yes, of course, after deleting 50, how front wraps around and says now 60 is the frontmost. And rear is still 1. Obviously 70 is the last element, but now 60 has become the frontmost. And finally we return x, that is return 50. So you can execute this two more times. Why I'm saying two more times is because now only two elements are left out, 60 and 70. And understand what happens when you delete those elements also. So watch it. If you execute delete, x will be equal to a front, but front is at the moment 0 and a0 is 60. So x becomes 60. We then inquire, is front equal to rear, which is false because front is 0 as you see in the box and rear is 1. So they aren't equal. So we go to else and execute the line where p arrow front becomes p arrow front plus 1, that is 0 plus 1 percent size, that is percent phi, that is 1% phi, 1% phi is 1. So the new value of front is 1. Now you just check, we have deleted 60, so the new front has to be 1, isn't it so? So now front is 1. I'm just overwriting this, just please manage this, I'm not erasing it. Front is 1 and rear is also 1. What do you know about the queue now? There is only one element pending in the queue, which is 70. And what if you delete that also? If you delete 70 also, then nobody can become front, nobody will remain rear because the only element 70 is getting deleted. Then you should make both front and rear minus 1 to indicate that now the queue is empty. Isn't it so? So let's execute delete to delete that only element pending. If you call delete, x will be equal to 70 because front is 1 and a of 1 is 70. And then we check, is front p arrow front equal to p arrow rear? You note both are 1 now. What that means is there is only one element in the queue and even that is getting pulled out. So after deleting that only element pending, we should make front equal to rear equal to minus 1. So both front and rear become minus 1. Just manage this bit shabby here, but just check this. Both will become minus 1. Come on, if 70 is also getting deleted, then nothing remains in the queue. So you should make both of them minus 1. Of course, else will not execute if was true and we finally return 70. Now the queue is empty, isn't it? Queue has become empty. We have also written empty function as usual, and you know that the queue is empty if p arrow front is minus 1, then return true, otherwise return false. And also this delete function is called from main in case 2 as in our earlier programs. If option 2 is given for delete, that's the option in the menu as you see. Second option is for delete. And if second option is true, then we first check, is the queue empty? If the queue is empty, we don't go for delete. But if the queue is empty, we will print it is underflown. There is nothing to delete in the queue. But if this condition is false, only then we proceed to call delete and we print the deleted element. That's how the delete function works. Very interesting. How the circular nature of this particular queue can be seen even in insert and in display. And the magic was done by percent operator, isn't it? As you saw, when rear was 4, 4 plus 1 became 5 and 5% phi has to be 0. So from 4, front counter went back from 4 to 0. That's the circular nature. When we meet in the next video, I will tell you how display function works. And display function of circular queue also uses a kind of percent operator, just as the other functions use. This is that particular expression that we will discuss while displaying a circular queue. Thank you very much.